Welcome, architect. Look, as a master stonemason, I've put together this explainer to show you exactly how we can elevate stone from, just a simple cosmetic veneer to a highly capable, truly sustainable structural material for your next major project. We're going to bridge that gap between traditional craftsmanship and modern structural demands. So let's forget about pouring concrete for just a minute and let's talk about building with the actual bones of the earth.
Right, let's dive into this consultation by remembering something fundamental. Stone moves from utilitarian resource to cultural expression. The material we choose today, it's going to outlast single lifetimes, anchoring your architectural vision directly into history. You're not just building for tomorrow, you are literally building a legacy.
Before we break ground, here's our blueprint for today. 1. The geology of construction. 2. Rubble, the rustic puzzle. 3. Ashlar, precision and polish. 4. Modern stone engineering. And finally, 5. The sustainable future.
Let's start right off with Section 1, the geology of construction. Selecting the right raw material.
Okay, so because you draw the lines, but I'm the one who actually has to make them stand, we need to know exactly what earth we're building with. The absolute crucial point we need to establish right out of the gate is what the industry calls fitness for purpose. This means rigorously evaluating a stone to ensure its suitability for a particular use based on things like stain resistance, shear strength, abrasion resistance, and long-term durability. We can't just pick what looks pretty, right? We have to pick what performs.
And notice how your functional choices map directly to the rock type. Like, do you need the sheer load-bearing grit of an igneous rock, like granite? That gives you unmatched compressive strength of 100 to 300 megapascal. Absolutely insane. Or maybe you need the high workability of sedimentary sandstone, though keep in mind, it is porous, up to 12% water absorption. Or perhaps your facade calls for the refined texture of metamorphic marble, known for its incredible ability to take a high polish. Your choice here basically dictates the whole shebang.
Moving on to Section 2, rubble, the rustic puzzle, the foundation of stone construction.
So let's look at our first traditional assembly method, rubble masonry, where we basically use the raw, chaotic nature of the quarry to our advantage. As an architect, you're facing a fundamental trade-off here. On the pro side, rubble is highly economical and utilizes natural, unfinished stones. Plus, it provides this beautiful, rustic appearance and is excellent for massive retaining walls and deep foundations. But the cons? Well, it relies heavily on highly skilled labor for packing, contains irregular joints with a less formal aesthetic, and it strictly requires spalls and sneaks, those are the tiny stones, to safely fill internal gaps. Honestly, it's exactly like assembling a giant three-dimensional puzzle where each piece is completely unique. When my crew and I lay uncoursed rubble, we aren't just blindly stacking rocks. We're solving a complex puzzle right there on the fly to ensure structural integrity across a massive surface area. Every single stone has to find its perfect interlocking home. Depending on the aesthetic and structural base your project needs, we can use a few variations. There's uncoursed random, which uses contrasting sizes for even pressure distribution. We can step it up to coursed rubble, where roughly shaped stones are organized into horizontal layers. We could use polygonal, fitting multi-sided stones closely to avoid vertical joints. Or we can use flint, utilizing extremely hard, durable silica nodules. All of these bring a really organic, grounding energy to the architecture. But maybe your design calls for something a bit more formal. That brings us to Section 3, ashlar, precision and polish, the pinnacle of craftsmanship. This is where we bring meticulous order to that chaotic, raw stone. To achieve that grand finish, my crew goes through some rigorous prep steps. Step 1. Splitting and sawing blocks to exact geometric dimensions. Step 2. Fine chisel dressing to ensure perfectly uniform faces. And Step 3. Chamfering exposed edges at 45-degree angles to add a real architectural resilience against the elements.
Like the quote says, this is precision furniture making applied to massive stone blocks. We're cutting these stones to such exact tolerances that our mortar joints shrink down to 1/8 of an inch or less. It creates an almost seamless appearance that just screams permanence.
Which leads us perfectly into Section 4, modern stone engineering. Reinventing load-bearing stone.
This is where we bridge my traditional craft with your high-tech engineering. Enter massive precut stone. This is a design for manufacture and assembly, or DFMA method, using large machine-cut blocks dropped right into place by crane for rapid load-bearing construction.
We completely eliminate curing delays. It's incredibly fast, highly precise, and just structurally phenomenal.
And we aren't stopping at simple stacking. No way. We now use post-tension systems that actually thread internal tendons right through the stone. This creates a high-performance tension-resistant composite material. Suddenly, this allows stone to be used for horizontal beams and flexible footbridges. It even enables highly resilient, unreinforced multi-story towers. We're literally making stone perform right alongside modern steel.
Okay, let's dive into our final piece. Section 5, the sustainable future, the environmental imperative.
Because the materials you specify today dictate the carbon legacy of tomorrow. 1/10. 1/10. This is the number that should absolutely change how every single architect designs. Load-bearing stone construction emits around 1/10 the carbon of a comparable concrete building.
Just look at these carbon emissions in construction. Load-bearing stone sits way down at 10, while steel-reinforced concrete is skyrocketing up at 100. Relying on heavily processed, coal-burning concrete when we have a naturally strong alternative ready to go is, well, it's increasingly hard to justify, right? Plus, the benefits go way beyond just carbon. Traditional mass masonry manages moisture naturally. It provides excellent thermal mass, and this is huge, it allows massive blocks to be completely reused in future structures. It is the ultimate recyclable material. So, as you pack up your blueprints and head back to the drafting table to design your next great structure, I really have to ask you, will you build for the moment or build for the centuries? The stone is ready when you are. Thanks so much for joining me on this explainer.